Laplace transform of periodic functions. So when we say that a function is periodic, if f of x plus t is equal to f of x, then that respective function is called a periodic function with a period 2. So this t we can also call it as primitive period. So simply the primitive period is nothing but primitive period. So this primitive period, we take the least period of that particular function. Just if you observe the periodic function, just you take any one of the example of the periodic function. Just I will show you graphically. So we have seen in the Laplace Fourier transform or Fourier series, sine and cos are the periodic functions. So here I have taken the cos x or you take sin x graph. Observe this graph carefully. Now, if you we have seen in the Fourier series a function in the interval 0 to 2 pi, 0 to 2 pi, 0 to 2 pi. Look at this graph, 0 to 2 pi. What it is there, then if you continue the same, it will repeat the same graph for the 0 to 4 pi. Look at 0 to 2 pi, it goes something like this, and 2 pi to 4 pi also we are going to be get the same. So it is repeating within this interval what the value we are getting, the same values it is we are getting in the 2 pi comma 4 pi. So therefore the periodic interval of this function is 2 pi. Length of this is called period of the function. So usually we'll take 2 pi is a period. Either you take from minus pi to pi or minus pi to pi, minus pi to pi or 0 comma 2 pi. Look at, if you take minus pi to pi also, you'll get the same. What the graph we are getting, the same graph it will get from pi to 2 pi. So pi to 2 pi, pi to 2 pi, like this the graph we are going to be get it. So finally, simply the periodic functions with a period. That way we are going to be find using of f of x plus t is equal to f of t. Now for that periodic functions, we are going to be find the Laplace transform. So to find out the Laplace transform of that kind of periodic functions, so just we use this respective formula. Just observe. See the definition. If f of t is a periodic function with a period t, so what is the period of that particular function that I am denoting with t? Then the Laplace transform of that particular function f of t is given by. So we find the Laplace transform of that kind of functions to get here. Laplace of f of t is equal to 1 by 1 minus e power minus st integral 0 to t e power minus st f of t dt. So using of this formula, we are going to be find the Laplace transform of periodic functions. Now we'll see one example how we are going to be apply, how we are going to find the Laplace transform of periodic functions. Okay, find a Laplace transform of the square wave function with the period 2 pi. So it is a square wave function with the period 2a, defined as that function is defined something like 0 to 2a, the function is defined as k, a to 2a, the function is defined minus k. So if you try to see what is the square wave function, just I'm googling, just will see what is the square wave function. Square wave function, square wave image or square wave function image like this. So just I'm taking one of the image of this. Look at here. So it is something like moving like a square. So what length it is repeating, based on that we call it as a period. So for the same function I am applying here from 0 to a. Look at this, we consider something 0. So 0 to this point you consider something a. So from 0 to a, the value is k. So this is you consider some k. A to 2a, the function is minus k. Look at you. So it is defined something like 0 to a, then a to 2a, the function is defined like this. So if you repeat the same 2a to 3a, it is plus k, and 2a to 3a, it is minus k. So therefore it is same square repeating n number of times. So what is the length of the interval 0 to 2a? Then this complete graph we are getting. So therefore the period of that respective function is 2a. So like this will see, this is called a square function, rectangular function, like many different functions. So triangle function, rectangle function, square wave function, periodic function, many different functions. So that we define mathematically. So for this function, we are going to be find the Laplace transform. So given function is a periodic function with a period t. So with a period is 2a. It is clearly given. Or else just we construct the graph and we see. Now according to the formula, we have Laplace of f of t is equal to 1 by 1 minus e power, this is minus st, integral 0 to t e power minus st f of t dt. So just we substitute that respective given function. So what is the function it is given? This is a function. So 1 by 1 minus e power s. So t is a period. Period of that respective function is 2a. So therefore we substitute here. So integral 0 to t. T is period. Period is 2a. E power minus st f of t dt. What is f of t? This f of t is defined from 0 to a is defined as k, from a to 2a defined as k. So therefore this interval also will split into two parts, 0 to a to 2a. Then that respective function we are going to be substitute. Look at 1 by 1 minus e power minus 2as integral 0 to a e power minus st f of t. What is f of t 0 to a? That function is k. So k dt plus a to 2a e power minus st f of t. What is f of t? F of t is minus k dt. Just apply the integration and substitute the respective limits. Okay. So 1 by 1 minus e power minus 2as is as it is. K is a constant, just I'm taking out. So integral e power minus st. So integral e power minus st is e power minus st and t coefficient is minus s. So that will be right in the denominator, minus s. Integral limit 0 to a. Integral limit 0 to a. Minus k is a constant, just we take out minus k. So integral of e power minus st, integration is e power minus st. The t coefficient is minus s, right in the denominator. And integral limits a to 2a. So substitute that limits and simplify. So this is as it is. This minus s I'm taking out. So therefore it will be minus k by s. So substitute the upper limit in place of t. So therefore it becomes e power minus as minus substituting lower limit. T is equal to 0. So e power 0. E power 0 is 1. So therefore this term is over. So this minus k I'm taking out, minus of minus plus. So therefore it will be k by s. Substitute the upper limit here. So if I substitute the upper limit, e power minus 2as, and substitute lower limit minus e power minus s. Now simplify this. 1 by 1 minus e power minus 2as. So k by s same. So therefore I'm taking only k by s common. So therefore this minus is inside, minus e power minus as. So minus of minus plus 1, and here from the second term plus e power minus 2as minus e power minus as. So therefore this is as it is 1 by 1 minus e power minus 2as k by s is as it is. Now this it is something like in the form of a square plus minus 2ab plus b square. Look at it. This I'm adding minus e power minus s minus e power minus s can be written as minus 2 e power minus s. So this is as it is, and this one. So therefore this you take as a square. This is 2ab and b square. So therefore this is in the form of a square minus 2ab plus b square. So we'll write it as a minus b whole square. So a is what here? 1. B is what here? E power minus s. So therefore this is as is 1 by 1 minus e power minus 2as 1 minus e power minus s square k by s is as it is. So now to making up this cancellation, this is we write it in the form of a minus b, a plus b. So this is in the form of a square minus b square. So therefore we'll write 1 minus e power minus s into 1 plus e power minus s. So therefore one term and one term here get cancelled. So therefore the remaining term here. So k by s into 1 minus e power minus s divided by 1 plus e power minus s. So like this we'll find out the Laplace transform of periodic function.